Yeah, we'll start. Others will join. We'll start now. We have waited too long. We'll be starting. So last class we had completed these things, temperature inversion and everything. Gaussian Plum equation also we had completed. Today we'll start with monitoring of air quality. How we'll monitor air quality and its impact. Okay. So there are two ways of monitoring air quality. One is station-based, another is satellite-based. Station-based monitoring, obviously, is known for the quality of air by generating vast amount of data on concentration of each air pollutants, SPM, RSPM, NOx, SO2, etc. in different parts of the world. The urban area may be viewed as dense source of enormous anthropogenic emission of pollutions, which can alter the atmospheric composition, chemistry, and life cycle. In India, air pollution has increased rapidly because of intensive population growth, increase in the number of vehicles, use of fuel with poor environmental performance, badly maintained transport system, poor land use pattern, industrialization, and above all, ineffective environmental regulation. So these are the main causes due to which we have deteriorated air pollution has increased in India. Okay. So the air quality monitoring program in India was started in 1967 by the National Environmental Engineering Research Institute, NERI, and the monitoring was expanded to include regular monitoring at 3 stations in 1978, and the CPCB initiated a National Ambient Air Quality Monitoring (NAQM) program in year 1984 with 7 stations at Agra and Anapara. Subsequently, the program was renamed as National Air Monitoring Program under NAMP. 4 air pollution, sulfur dioxide, oxides of nitrogen, and suspended particles respirable suspended particles matters have been identified for regular monitoring at all the locations. So detailed guidelines of these air pollution monitoring are given in central pollution. Okay, what things should be on, what is the limit for it, all should be given. So this is station based, where we collect the data from the different parts of the cities or villages or areas in the earth. Then is the satellite based monitoring. So it is not the traditional method which is station based. There are some modern techniques or tools that are also widely used and accepted today. The traditional sampling method for environmental monitoring of air pollution is time consuming and expensive. Furthermore, field measurement cannot provide the fine spatial resolution needed to show detailed distribution pattern over a large area. So these data which we get from stations are small data, or the data of a small area. Okay, that is why we need further improvement in the monitoring system. So furthermore, field measurement cannot provide the so remote sensing techniques can overcome these problems. Radiant energy reflected and emitted by the earth carries with it a signature of the Earth's atmosphere, and such characteristics by measuring the wavelength and the angular of polarization properties of this energy, satellite sensors can quantify several atmosphere and surface features. Okay. Do you know why the sky looks blue? Anybody can answer why the sky looks blue? Nobody. Any answer? Why the sky looks blue to us, not of any other color? Okay. Actually, the sky is looking blue because of the scattering of the light. When the sunlight is coming and it passes through layer, okay, the blue light is able to penetrate and come. So it looks blue to us. So obviously, these air particles and all these things, they keep changing the reflection of light reflection. And these reflections are caught by the satellites, which are geostationary satellites or satellites which are hovering around us, okay, all the time. Okay, so these satellites, what they do, they receive the reflected air, and from the reflected air, they give can predict the atmosphere how it is. Okay, satellite data have traditionally been used to detect air pollution and can be used for qualitative measurement over a large coverage area. Mapping air quality by using remote sensing data provides better results at a relatively cheaper cost. Mapping atmospheric pollutant using remote sensing. The pollutant can be measured with the help of remote sensing as nitrogen dioxide (NO2), sulfur dioxide (SO2), ammonia (NH3), carbon monoxide (CO), some volatile organic compounds (VOCs), and aerosol optical depth (AOD), from which surface particle matter PM2.5 and PM10 may be inferred. So satellites can measure the most important air pollutant, aerosols, greenhouse gases, and particles such as those from dust, smoke, and pollens. They provide timely, spatial, explicit, large-scale information on the distribution in a cost-effective manner. When these data are compiled with ground-based measurement from monitoring stations and atmospheric chemistry models, accurate information on air quality can be provided in near real time to support air pollution mitigation and public health protection. So these data can be compiled, and by the way, with the help of this data, we can provide exact quality of the air in that area. Regional and municipal governments are increasingly interested in providing services to monitor and forecast local and city level air quality using models based on satellite data. The inventions of climate research through the use of satellite remote telemetry began on 1960s through development of space probes to study other planets. During the US economic decline in 1977, with much of NASA's money going towards the shuttle program, the Reagan administration proposed to reduce spending on planetary exploration. During this time, new scientific evidence emerged from ice and sediment core that Earth's climate had experienced rapid changing in temperature, running contrary to the previously held belief that the climate changed on a geological timescale. These changes increased political interest in gathering remote sensing data on Earth itself and stimulating the science of climatology. So when scientists came to know that the climate of the Earth is drastically changing, so the program to explore space was dropped and efforts or monies were spent on how to explore our own planet. These changes increased political interest in gathering remote sensing data on Earth itself and stimulated the science of climatology. That's what we call as climatology. Based on the type of air and the monitoring, there are two types of air quality: ambient air monitoring. This is done for the ambient air through though mostly high volume samplers, as the pollutions in the air are in dilute and dispersed condition. For detection of air pollutants, high volume of air is necessary to be sampled. So the detailed methods of sampling and measuring is given in CPCB manual. Okay, this is a manual which is given. So as the air is very disturbed, that is a high volume of sample is required so that we can monitor the ambient quality of the air. Then stack monitoring, this is source emission monitoring. Air pollutants are sampled and monitored directly from the stacks or chimneys. And the detailed methods of stack monitoring is given in CP here also given. So one is monitoring the air in a normal place, other is monitoring the air around the chimney. Okay, so that is one is ambient and other is the stack monitoring. Then why air quality standards? After monitoring of air quality, the concentration of air pollutants can be compared with standards to know the pollution status. Okay. So air quality standards were first developed by US EPA or US Environmental Protection Agency for ambient air. Then through Clean Air Act, it was legalized. WHO also provides guidelines for ambient air quality, which are as follows. Guideline value prescribed by WHO is PM 2.5, 10 microgram per meter cube, annual mean. Then 25 microgram per meter cube, 24-hour mean. PM 10, 20 microgram per meter cube, annual mean. 50 microgram meter cube, 24-hour mean. And ozone, 100 microgram per meter cube, 8-hour mean. Nitrogen dioxide 40 microgram per meter cube annual mean, then 200 microgram per meter cube 1 hour mean, then sulfur dioxide 20 microgram per meter cube 24-hour mean, 500 microgram per meter cube 10 minutes mean. In India, ambient air quality standards are under the air prevention. Hello. So in India, this ambient air quality standards is under the Air Prevention and Control Pollution Act 1981, and these are the things which are included under ambient condition. Okay, first is the pollutant, then the weightage average, then concentration in ambient air and methods of measurement. First is the sulfur dioxide annually 24, industrial residual is 50 and 80, and ecologically sensitive area is 20 and 80. So improve waste and geek methods and ultraviolet fluorescence. These are the methods by which they are measured. Then nitrogen dioxide annually 24 hours, 40 and 80, 30 and 80. Jacob and Holzhausen modification method and gas phase chemoluminescence. Then particle matters of size less than 10 micrometer or PM10 microgram per meter cube, annually 24 hours measured, and 60 and 100 and 60 and 100. This is by a gravimetric TOM or beta attenuation. Then particulate matter size of less than 2.5 micrometer or PM 2.5 microgram per meter cube, that is also for 24 hours. 40 and 60, then it is also same. So annual arithmetic mean of minimum 104 measurements in a year at a site taken twice a week, 24 hours at uniform interval. This is how the readings are taken. 104 measurements in a year at a site taken twice a week. In a week, twice they will be taken. 24 hours at uniform interval. For the 24 hours, they will be taken at a uniform interval. Means it may be 1 hour, half an hour, 2 hours, but it should be of uniform equivalent. So apart from ambient air quality standards, vehicular standards also exist. Following European regulation vehicular standard (Euro standards) were first introduced in 2000. Gradually, strict norms have been introduced since then. After the implementation of the norms of all vehicles manufacturers must comply with the regulation in India, Bharat Stage Emission Standard (BSES) are commenced by the Government of India. So BSES is the engine type which are running in India. So the BSES standards are to regulate the emission of air pollutants from internal combustion engines and spark ignition engine equipped, including motor vehicles. In October 2010, Bharat Stage 3 standards have been imposed across the country. Bharat Stage 4 emission standards have been enforced in 13 major cities since April 2010, and it has been improved for the entire country since April 2017-16, and the Government of India announces that the country would skip the BS5 norms although and adopt to BS6 norms by 2020. The standards are given in table 2.4. So this is a table which shows according to which norm how much carbon monoxide, how much nitrogen dioxide is applied in the emission. So these are the different norms according to which our engines are made. Then air quality index or AQI. Just give me a minute, I am coming. So air quality index is one of the important tools available for analysis and representing air quality status uniformly. The air quality index AQI can be used as a measurement to assess the relative change in the concentration of the group of pollution in two situations. The situation may represent either two time periods or two regions. Thus, there are several methods to calculate air quality index AQI, and AQI is a communication tool, but the effective communication of air quality information still needs improvement and monitoring networks. Maybe ill-equipment to provide the appropriate information. However, AQI may not accurately reflect our current understanding of the adverse health effects of ambient air pollution. It typically fails to recognize low level exposure and addition contribution of the multiple pollutants. Although AQI can be used at the research level, the original quality assured data is often more appropriate than that's why main rationale to AQI remains as a tool to provide air quality information to the public. So when available on the internet, they can display current information and background material of the air quality. Though air quality index is a way to measure, but it is not appropriate. Okay. So it started in New Delhi on 17th September 2014 under the Swachh Bharat Abhiyan, an expert group including air quality experts, medical professionals, academia, uh, advo- advocacy groups, and state pollution control board was created, and a technical study was conducted by IIT Kanpur. Expert groups and IIT Kanpur recommended an AQI scheme in 2014. While the former measurement index was restricted to three indicators, the new index comprises of 8 parameters. The non-stop monitoring system that displays data on nearly real-time basis are mounted in New Ahmedabad, Delhi, Mumbai, and Pune. So this is you must have seen this uh, type of boards in Bhubaneswar also. Near the traffic, you will see boards like these are present where AQI is displayed regularly. Okay. So if it is green, then it is good. If it is little less green, it is satisfactory. If it is pink, then it is moderate. If it is orange, then it is poor. And if it is red, it is very poor. The air quality of air is very poor. And all these things are done by monitoring these different things: PM10, PM2.5, NO2, and then ozone, carbon monoxide, and sulfur dioxide. So there are 6 AQI. The recent planned AQI will conduct 8 pollutions like PM. Okay, all these are there. Okay. Then what are the associated health impact with the air quality index? If it is good, then minimal impact on your health. Satisfactory may cause minor breathing discomfort to sensitive people. Not all, only the sensitive people will have minor breathing discomfort. Moderately polluted may cause breathing discomfort to people with lung disease such as asthma, and discomfort to people with heart disease, children, and old adults. Poor may cause breathing discomfort to people or prolonged exposure and discomfort to people with heart disease. Very poor may cause respiratory illness to the people in prolonged exposure. Effect may be more pronounced in people with lungs and heart disease. Then severe may cause respiratory impact even on healthy people, and serious health impact on people with lung and heart disease. The health impacts may be experienced even during light physical activity. Then indoor air quality. Indoor air quality refers to the physical, chemical, and biochemical characters of air inside our home, a building or institution or commercial facility. So the air which is inside our house or home or offices, we call it as indoor air. So indoor air pollutant refers to the increase in the concentration toxic contaminants that we encounter in our daily lives. to level higher than that acceptable in home, institutions, workplaces, etc. It is a matter of concern in developed and developing countries where energy efficiency improvement sometimes make houses relatively tight, reducing ventilation and raising pollution levels. Okay, as the places were not perfectly ventilated, due to which the indoor air pollution increases. So what are the causes? First is rural area, developing countries, burning of traditional fuel like wood, charcoal, cow dung for cooking and heating purpose. Then urban areas, construction of tightly sealed houses with least ventilation, use of synthetic material for building and for furnishing, use of chemical products, pesticides, household care products. These are all the causes of your indoor air pollution. Sources are tobacco smoking, carbon monoxide, nitrogen dioxide from unvented or faulty gas appliances, soot from wood burning stoves, fireplaces, aerosol spray, biological agents, egg space, dander, dust, molds, etc., asbestos, radon, Class-4, and lead. All these causes indoor air pollution. Effects: lung cancer. Random exposure is the second leading cause of the cancer. So what happens? These pollution, as we are not aware, we inhale them, due to which we end up with lungs cancer. Then respiratory disease such as bronchitis, pneumonia, and emphysema, heart disease, headaches, loss of eyesight, impaired mental function, eye, nose, and throat irritation, allergic reaction, damage of liver, kidney, and brain. These are all the effects of indoor air pollution. Then prevention: avoid smoking indoor, using products and appliances safely, produce products containing VOCs should be used outside wherever possible, and indoor only in proper ventilated area. Choose alternatives to aerosol spray whenever possible. Choose housing material, furniture, paints, and carpets carefully. Cleaning of house at regular to keep it free from the dust and mold. Okay, these are all the prevention measures which you can take so that the air pollution can be prevented inside our home. Examples: carbon monoxide produced by appliances or heaters that burn natural gas, oil, wood, propane, or kerosene, also a major component of car exhaust. This is the carbon dioxide which comes out. Then tobacco smoke, comprised of diffused chemical compounds. Then radon. Tobacco also composed of different chemical compounds. Radon comes from natural breakdown of uranium in rock and soil. It can seep into homes through cracks in the floor and walls. In molds, require moisture to grow and tend to be found in damp basements. Refrigerators are seep into our home and causes indoor air pollution. Then molds, where moisture to grow and tend to be found in damp condition, humid mattresses, carpets under ceiling panels or behind wall. This is where the molds can grow. Then solvents, household cleaners, uh, degreasers, greasers, art and craft supply, globes, then VOCs, hairsprays, deodorant and fresheners. All these are VOCs. So all these are the sources. They are preventive measures for the control of air pollution. Then comes your water quality. Then water quality and its impact. So water, already you know it is a natural resource. How it is found in different forms, I have already discussed with you. Okay, realize the importance of water, assessing the influence of various natural resources on water, assessing the effect of contaminated water on environment. So after reading, students will be able to realize the importance of water quality in daily life, assessing the influence of various natural processes to determine water quality, explain the effect of environmental water on underground water on even. Then, then the concept of water quality. According to who, water quality is a term used here to express the suitability of water and sustainable various uses or processes. Then water quality play a pivotal role in public health, habitat phenomenon. So water quality plays a pivotal role in public health. Okay, if the water quality is not good, it will not supply to the public. Okay, so maximum interest is statutory health. So drinking water supplied and specialized industries, manufacturers, exports the most sophisticated demand on water quantity, but large demanded for water quantity, such as for agriculture, irrigation, of reaction effects during air products and then drinking water supplies are specialized industries may say even the most severe demand on water quality but large demand for water. So these most severe on water quality but large demand of water quantity such as for agriculture, irrigation, irrigating crops require the pH in terms of water quantity. In parallel, since ancient time, it is most important, most stable medium to clear, disperse, transport. So when we are going for household using of the water, we go for quality testing. But when we are going for agriculture perspective, are going on quantity of water, not the quality of water. In parallel, since ancient time, it is most suitable medium to clean, disperse, transport, and dispose of waste. It's a challengeable medium to clean, disperse, transport, and dispose. It is a challenge to maintain water quality against point sources and non-point sources. As compared to NPS, PS can be distributed only by as they are discrete sources rather than diffuse. So the amplifier transforms of nutrients to waste bodies is a result of the day to day improper land use and so the intricacy of NPS identification is enhanced as the importance between precipitation and landscape character increases. That is, improved surface runoff uh, runoff increases. In developed countries such as Nepal, India, Bangladesh, and China, the pollution of a river is severe due to the urban activities. Here, humans strongly influence and their almost very major aquatic ecosystem, altering the fluidities of grown limited mammals. Though our rivers are being polluted because of our household water which is getting mixed to the river. Okay. So accessibility for disposal of wastewater in surface water makes it more exposed to the pollutants, anthropogenic activities as well as natural processes such rainfall and urban or rural runoff. Determinate surface water for consumption, recreational and other purposes, and these activities great have a dining period. So anthropogenic activities as well as natural processes such as rainfall and urban or rural runoffs deteriorate surface water for consumption, recreational and other purposes, and these activities have a direct impact on water quality. And these natural anthropogenic processes in addition act as a pool and effectively adversely affects quality ecosystem by metal release. So now we'll see about the different processes which are affecting the water quality. Although demonstrated water quality is almost always the result of the anthropogenic activity, specific natural phenomena can result in water quality detection below the required permissible limit for various purposes. So natural measures can such as heavy rainfall and hurricanes can limit for this purpose. Natural resources such as heavy rainfall and hurricanes can lead to severe erosion and landslides, which in turn can increase the concentration of suspended materials in affected rivers of the lakes. Then natural measurements such these are the things. Then periodic overturn of water in some lakes can transport water with little or no reserve oxygen to the surface. Such natural events can be recent or infrequent. Then land natural conditions in some part may make water unfit for drinking or for explicit use such as irrigation. Common insulated instances of these are the salination of surface water, so evaporation in arid and semi-arid regions, and the high salt concentration of groundwater in certain geological environments. Many groundwater as well as high concentration of carbohydrate hardness are necessary The seed treatment before use of industrial pesticide. So these are the pH conditions where they are problem. Then we'll come to groundwater in some area contaminated contains some ions such as fluoride and toxic elements such as arsenic and selenium in amounts that can be damaging to health, while others are contains elements or compounds that can be origin of other types of problems such as tinting and stinting of sanitary fittings by iron and manganese. The type and amount of chemical elements and compounds in a freshwater system are subjected to change by various types of natural processes, that is physical, chemical, hydrological and biological. So the most important processes and the waste water bodies they affect are listed in the table. So the table above gave those information. Then the most important environmental affecting water qualities are distance from ocean, amount of sea spray, rich in sodium, magnesium, calcium and phosphate, sulfate and other ions, climate and vegetation. It determines the amount of erosion and mineral weathering and amount of dissolved material, so evaporation and evapotranspiration in humid climate. Mineral weathering is more and thus dissolved solid will be more, whereas in arid climate evaporation will be more, hence the water quality will be evaporation dominant, that is the natural water will be rich in evaporates and high concentration of dissolved salt. Vegetation cover will prevent erosion of soil and thus surface runoff will be less. Consequently, the surface water bodies nearby will be lesser suspended solid load. That is why it is important for us to plant trees, okay, so that we can stop soil erosion, and that's so when soil erosion stop, it will also decrease the water pollution. Then it is rock composition or lithology. The vulnerability of rocks to weathering depends on the rock type. For example, granite is resistant to weathering, whereas limestone has much greater susceptible for weathering. So type of rock, on the type of rock, the weathering of the rock depends. So more highly soluble rocks are more valuable to natural weathering processes, vulnerable, and thus will impart more amount of dissolved salts, cations and anions in the natural water. Terrestrial vegetation, the decomposition of terrestrial plant tissues in soil affects the quality of the organic compound and nitrogenous substances found in the water. Then aquatic vegetation, the growth, death and decomposition of algae and aquatic plants will influence the concentration of nutrients like nitrogen and phosphorus. The decomposition of aquatic plants may also alter the pH, carbonates, dissolved oxygen and different chemicals which are sensitive to oxidation reduction condition. Aquatic vegetations have more effect on the chemistry of the standing water bodies like lake waters and less pronounced but significant effect on flowing water or river water. So these are the different natural processes on water bodies. First is process is hydrological. The major process is dilution, evaporation, percolation, and suspension and settling. Okay, water bodies is all water bodies. Dilution is there. Surface water only evaporation is there. Then percolation, leaching in groundwater. Suspension and settling in surface water. Then physical, gas exchange with atmosphere, volatilization, absorption, dispersion, heat and cooling, and diffusion. Gas exchange with atmosphere mostly rivers and lakes. Volatility mostly rivers and lakes. Absorption and disposition all water bodies. Heating and cooling mostly rivers and lakes. And diffusion it is not given. Chemicals, photodegradation doesn't happen. Then redox acid-base reaction in all water bodies. Redox reaction all water bodies. Dissolution of particles all water bodies. Precipitation of mineral all water bodies. Ionic exchange only in groundwater. In biological, primary production surface water. Microbial die-off in the growth all water bodies. Decomposition of organic matter mostly rivers and lakes. Bioaccumulation mostly rivers and lakes, and biomagnification also mostly rivers and lakes. Then effects of hydrogeochemistry on water quality. A rock first is a rock type. The mineral composition of a aquifer is majorly responsible for the geochemistry. Depending on the geology and chemical characteristics of the aquifer, the hydrochemical processes and hydrogeochemistry of the groundwater varies spatially or temporally. The hydrogeochemical processes may include processes like the dissolution, precipitation, ion exchange processes, general geology, degree of chemical weathering of the various rock types, and quality of recharge water, and the input from the sources other than water rock interaction at the residence along with the flow path controls the chemical composition of the groundwater. On the other hand, water rock intentions, these are variously functional and their interactions which results in the groundwater chemistry and hence gives complex groundwater quality. Factors such as hello Pushapre, will you please mute your mic? So they bring spatiotemporal variations in the groundwater chemistry as they alter the chemical composition of groundwater with respect to the space and time. Therefore, these hydrogeochemical processes present in the groundwater system helps in the deriving the contribution of rock, soil, water interaction and atmospheric influences on the groundwater. Groundwater is vulnerable to contamination process due to the presence of shallow aquifer. So urbanization, industry development, agri activities and mining are also increasing the threats of pollution aquifer around the world. Then geochemical processes, groundwater reacts to different levels with the surrounding minerals or other components, thus giving groundwater its characteristics chemistry. For instance, silicate mineral present in most rocks do not react readily with most groundwater, but the carbonate mineral easily reacts with groundwater and plays a significant role in evolution of many groundwater. Then carbonate reaction among various minerals. Carbonates are the most commonly found minerals in various types of rocks, sedimentary rock and rich in carbonates. Hence some igneous and metamorphic rock also contains carbonates. Hence carbonates chemistry and weathering are of great relevance to determine the groundwater quality. The calcite dissolution is as follows. Calcium carbonate plus CO2 give H2O plus calcium to HCO3. First step of this reaction is formation of carbonic acid. CO2 plus H2O gives H plus HCO3 minus. This is the first reaction. Carbonic acid is produced which promotes the dissolution of calcite, that is formation of calcium bicarbonate, which is water soluble. Calcium bicarbonate from the first reaction, it is evidence that calcite solubility depends on amount of carbon dioxide available, and calcite solubility is also dependent on pH. Acidic pH will lead to more dissolution of calcite and oxidation of sulfide minerals, or reaction of gaseous sulfur pollutants like hydrogen peroxide also produces hydrogen ion that will lead to the dissolution of calcite. Then oxidation reduction reaction. Oxygen is the most common oxidant, sulfide minerals and reduced forms of iron are commonly found reductants. So when water infiltration into the ground, it becomes isolated from atmosphere. Oxygen and becomes more reduced as it reacts with reducing agents such as organic matters and sulfide minerals. Many elements can occur in more than one oxygen states having different solubility. For example, ferrous iron is soluble in water while ferric iron is insoluble. The chemistry of arsenic is also governed by the oxidation and reduction. So according to Stanley and Kingsbank, there are two abundance of arsenic in rock and sedimentation and the igneous rock, basically basalt, acidic granites, metamorphic rocks, then sedimentary rocks, limestone, depends upon the redox reaction and pH condition in the groundwater. Arsenic is found in many forms. It occurs mainly as oxyamino or against the cation found for most toxic elements. Oxyamino tends to dissolve with increased pH, hence at lower pH to a lesser extent can absorb to a range of aquifer minerals like aluminum, iron, Mn hydroxide and K minerals. The most important sorbitants are iron oxide, ferrous oxyhydroxide and geothite, which have strong torsion sites and are abundant as grain coating in many aquifers. Freshly precipitation metal hydroxides promotes adsorption, whereas aging mineral surfaces, presence of competing anions such as phosphates, bicarbonates and silicates in groundwater decreases the absorption of arsenic. So the mobility of arsenic is dependent on the precipitation dissolution reaction. Then aquifers related to large amount of fresh organic matter. or over mineralization in hydrothermal systems with temperature greater than 100 degree creates strong reducing conditions leading to arsenic formation, erosionophrite. Under oxidized condition and low pH, arsenate is likely to be incorporated in iron hydroxide. It has been found that the competitive dissolution of organic matter helps in desorption from iron hydroxide. Studies have shown that the oxidation state of the water in an aquifer is directly proportional to the presence of high level of arsenic. Ion exchange processes, the ion present in the water being electrically charged have the tendency to be electrostatically absorbed into solid surfaces. Solid surfaces can be ordinary mineral grain, example feldspar and quartz, or mineral containing iron oxide and clay minerals, of which the latter is more efficient. Clay surfaces are negatively charged, hence they are more effective in adsorption of cation, but the absorption or desorption of the major cations found in the nature water have been fluorescentive. The following in the order is the in which they absorb: decrease, strongly absorb, calcium and magnesium, potassium, sodium, weakly absorb. So this leads to an ion exchange water softener, and the procedure known as base exchange softening is applicable as there is a pool of sodium ion adsorbed into clay mineral. But when natural water with calcium and or magnesium ion comes in contact, then preferentially they attach at the exchange site and sodium is released, exchange and mobilized in water. This in turn changes the pH and the equilibrium of the reaction moves towards right, hence increasing the bicarbonate level and the pH. So when calcium plus in the presence of carbon dioxide reacts with water, calcium carbonate, it gives calcium plus 2HCO3, and this HCO3 will decrease the pH level because it's a bicarbonate ion, and it will give you acid. Then weathering processes and water quality. Weathering processes are wear and tears of rocks due to physical, chemical and biological agents. Several weathering processes can influence water quality, specifically groundwater quality. Physical aspects of weathering: distinct differences in physical conditions, altering freezing and thawing and wet period, altering with severe drying, tends to rapidly weather rocks. Also, hydration and dehydration of rock causes swelling and shrinkage of minerals in the hence mechanically weathering the rock. Another factor is the growth of roots through tracks in the rock causing its weathering. Chemical weathering. Chemical mechanisms, namely dissolution, precipitation, acid-base reaction, and completion, hydrolysis and oxidation reduction, are majorly responsible for chemical weathering. Another crucial factor is temperature, because the rate of chemical weathering increases with the increase in temperature. Okay, so these are the different reactions of hydration and dehydration. How calcium sulfate reacts with water, forming calcium sulfate dot 2H2O, and iron FeOH gives FeO2 plus 2H2O. Then dissolution: calcium sulfate dot water gives calcium plus sulfate plus water. Then oxidation is FeS plus oxygen plus water gives Fe2O3xH2O and 8SO4. FeSiO4 plus 4CO2 gives plus 4H2O gives 2Fe2 for 4HCO3 plus H4SiO4. Then 4Fe8HCO3 gives O2 plus 2Fe2O3 8CO2 plus 8H2O 4H2O. Then dissolution with hydrolysis, calcium carbonate plus water gives calcium plus hydrogen carbonate plus oxygen and magnesium silicon oxide plus 4CO2 gives 4H2O plus 2 manganese plus 4CO3 plus H4SiO4. Then acid hydrolysis, calcium carbonate plus water gives CO2 plus calcium plus 2HCO3. Then completion, so K2 plus Al4O2 plus C2O4 gives Al2O4 and 6I and 6I and aluminum carbon oxide. Then the physiochemical parameters. So the good quality water is an essential feature for averting disease and improving quality of life. It is required to know details about several physiochemical parameters such as pH, color, temperature, total dissolved solid TDS, hardness, acidity, alkalinity, sulfate, nitrate, chloride, dissolved oxygen, biological oxygen demand, chemical oxygen demand used for assessing of water quality, physical, chemical. The first is the temperature. Temperature regulates the rate of all biochemical and biological reaction, and the seasonal and diurnal variation persist. Temperature is a significant factor to consider while assessing water quality. Temperature affects quality, a few other parameters, and can change the physical and chemical properties of water. In this aspect, water temperature should be measured for determining metabolic rates and photosynthesis, toxicity, dissolved oxygen DO, and other dissolved gas concentration. Then conductivity and salinity, oxidation, reduction potential, ORP, pH, and water density. Then electrical conductivity. As a result, salt is more conducive of electricity, and if there is large quantity of salt in a fixed volume of water, the electrical conductivity of water will be high, and in contrast to less saline water. The capability of a solution to conduct an electrical current is determined by the nature and the various types of ionic species in that solution. So this gives an idea about the total amount of dissolved solids in the water. In natural water, almost all the EC is due to the presence of the majority cations, sodium, potassium, calcium, and magnesium, and anion, nitrates, carbonates, bicarbonates, sulfates, and chlorides. And in acidic and basic water, the protons, hydrogen, and hydrolysis ion contributes extensively to the EC. So most organic compounds dissolved in water do not dissociate into ions. Consequently, they do not affect the electrical conductivity. Hydrogen activity or pH is significant parameter. We know that change in pH will change many things in the water. Okay, from total dissolved solid to all aquatic animals, even our drinking also. So the pH of the most natural water lies in the range of 6.5 to 9.5. Biological actions and anthropogenic activities such as nutrient recycling, cycling, and industrial influencer discharges respectively can influence pH fluctuation. Acid mining, drainage can have a noticeable effect on the pH. Further, acid forming gases released into the atmosphere such as sulfur dioxide and nitrogen dioxide may ultimately change the acid-base equilibrium in natural water and lead to a reduced acid neutralized capacity and henceforth a dropping of pH. The pH of natural water is influenced by various factors and processes, including temperature, discharge of effluent, acid amine drainage, acid precipitation, runoff, microbial activity, and decay processes. Total dissolved solid. We know that TDS is also an important factor. That is why all our aquaguard and everything, they have a TDS measurement system which measures the TDS. Okay, because total dissolved solid, if it is more, then the water is more polluted. Okay, because of the suspended particles. Then alkalinity, obviously alkalinity also affects the water. Okay, if the water is more alkaline, then there are presence of calcium carbonate, which is not good always. So a pH value of less than 8.3, the bicarbonate ions concentrated in the main form of the alkalinity have a pH value of more than 8.3 and 9.3. The carbonate and hydroxide ions respectively are of significance. Alkalinity can be neutralized in water by acid influx. So when acid influx prevails and neutralize the total alkalinity of water, the pH will decrease to below a pH value of 4 and acid will appear. So whereas when alkali is added to water, the alkalinity henceforth the pH will rise. So low alkaline water is also undesirable since the absence of pH buffer capacity related with low alkalinity may be favorable to corrosion. So a certain degree of alkalinity may act as a corrosion inhibitor. Very alkaline water is chiefly harmful in food processing and beverage production. Acidity is due to the occurrence of weak or strong acid. The dissolved carbon dioxide is generally the foremost acidic factor in unpopulated surface water, and in the form of H2CO3, carbonic acid. The acidity of water will affect palatability and corrosion. And total hardness, we know that hardness is also a factor. Hard water is not good for washing and everything, causes corrosion and deposition on the pipes and everything. Okay. So water hardness is the capacity of water to produce lather after reacting with soap. Hard water needed significant more soap to produce a lather. The hard water frequently produce a precipitable or insoluble metal, soap or salt. So in vessels, it is not produced by a single constituent but by several dissolved polyvalent metallic ions, chiefly calcium and magnesium ion. Although other ions, example aluminum, iron, barium, strontium, magnesium and zinc also contribute to the hardness, is most frequently expressed in milligram of calcium carbonate equivalent per liter. Water contains calcium carbonate at concentration below 60 mg per liter is generally considered as soft. 60 to 120 is moderately hard, 120 to 180 is hard, more than 180 is very hard. The hardness is caused by a cation. It might also be represented as in terms of carbonates or temporary or non-carbonate permanent hardness. If it is a carbonate, it is temporary hardness. If it is non-carbonate, the permanent. The main natural source of hardness in water are dissolved polyvalent metallic ions from sedimentary rocks, seepages and runoffs from the soil. Calcium and magnesium are the two principal ions exist in many sedimentary rocks, and the most common being limestone and chalk. Then chloride content. Chloride may be present in groundwater naturally and also come from diverse sources such as infiltration of seawater, weathering, leaching of sedimentary rock, etc. Chloride is a common anion of water and it is highly soluble and tends to accumulate once in solution. Characteristically, the amount of chloride in fresh water varies from a few to several hundred mg per hour. In ocean water, the concentration is very high, approximately 19800 mg per hour. Chloride source in surface water can be from immigration runoff, sewage, effluent discharge. So chloride sources in the surface water can be from irrigation, runoff, or sewage influences, discharges, and from industrial effluent. The taste and the corrosion threshold of chloride are dependent on the associated cations, pH of calcium carbonate concentration, high chloride concentration, and increase of corrosion. And the effect is synergistic when pH value are low. Then DO, diesel oxygen, we know that I've already told you before also. Diesel oxygen is the most important for the aquatic animals. If there is no diesel oxygen, all these aquatic animals, mainly fish and everything will die. Then biochemical oxygen demand is the quality of the diesel oxygen essential in mg per liter for stabilizing the biodegradable matter by microorganisms present in the water sample under aerobic environment and for the oxidation of other inorganic materials such as iron and sulfide. This is called as biochemical oxygen demand or BOD. So it is the oxygen which is required by living organisms. Okay. There are two phases of breakdown in the BOD test, a carbonate phase and a nitrogen phase. Carbonate phase, our first phase, signifies the portion of oxygen demand which is needed for oxidation of organic carbons to carbon dioxide. The nitrogenous phase or second phase signifies a collection of carbonaceous plus nitrogenous demand. So in this phase, organic nitrogen, nitrates and ammonia are transformed to nitrate. Nitrogenous phase typically starts after around 6 days. For some sewage water, particularly effluent from wastewater treatment plants, apply biological wastewater treatment processes. Nitrification can happen in less than 5 days, and if nitrifying bacteria, ammonia, nitrate are present in this case, an inhibitor or such chemical compound that stops nitrification should be added. If only the carbonaceous demand is to be measured, consequently the results may be reported as carbonaceous BOD, CBOBAD, and CBOD5 when a nitrifying inhibitor is used. So the standard incubation of oxidation of BOD test is 5 days at 20 degrees Celsius. Then COD, chemical oxygen demand, is the quantity of the dissolved oxygen required in water to cause chemical oxidation of organic material. Both BOD and COD are important indicators of the ecological health of the surface water. Then COD, chemical oxygen demand, is defined the amount of oxygen equivalent of organic matter of a sample that is prone to oxidation by strong chemical oxygen. Most of the organic matters can be oxidized to 95 to 100% of their theoretical value by strong chemical oxygen, and the COD consequently gives an estimate of the organic matter present in a water sample. In the aquatic bodies, usually organic matter is found as autochthonous organic matter which exists within the aquatic bodies itself due to the growth, death and decay of aquatic organisms, and allochthonous organic matter which comes from outside the water body. Agricultural practices, stock farming, and the generation of industrial and domestic waste are important source of organic matter in the water bodies. This organic matter is present either in dissolved or in particulate matter. Okay. Then organic matter can also lead to fouling of ion exchange, resins, electrodialysis, and pressure membrane filtration. The products of organic matter degrades while passing through ion exchange beads, can cause corrosion and erosion in stem and condensation return lines and cause problem in stem region. Chemical oxygen demand denotes the oxygen equivalent of the oxidizable organic and inorganic matter in a sample by oxidation with strong chemical oxidants. These exist a direct empirical relationship between COD, BOD and total organic carbon present in the sample. Then sulfates are a form of salt, mainly cations such as potassium, sodium, calcium, magnesium, barium, lead, and ammonium sulfate salts of potassium, sodium, magnesium, and ammonium sulfate are highly soluble, whereas calcium sulfate is less soluble, and barium and lead sulfate are insoluble. Sulfate commonly occurs in natural water from the dissolution of mineral sulfate in soil and rock, particularly calcium sulfate, gypsum, bearing rocks, and other partially soluble sulfate minerals. Typically, the concentration of sulfate in surface water is 5 mg per liter. Although concentration of several hundred mg per liter may occur with the dissolution of sulfate minerals or discharge of effluent, some acid mine draining takes place. Then sulfates are also discharged from other industrial processes such as tanners, textile mills, and processing using sulfuric acid and sulfate. Okay. Then atmospheric sulfur dioxide, these are also. Then nitrate, the source of nitrate is used mainly in organic fertilizer when it leaches to the nearby groundwater. They increase the nitrate. Just give me a minute. Nitrate can enter both surface water and groundwater because of the surface runoff and leach, and from wastewater treatment plants, and from oxidation of nitrogenous waste products from human and animal excreta, including septic tanks, chloramine addition as residual disinfectants, and stagnation of nitrate-rich oxygen-deficient water in galvanized steel pipes. So degradation of rock and all these are also the sources of nitrogen. Then phosphorus. Phosphorus may be in dissolved or particulate form. Dissolved phosphorus is available to aquatic organisms. It may enter aquatic bodies from leaching and surface runoff from fertilizers, crop residues, and humans or animal waste. A small amount of dissolved phosphorus occurs naturally in soil. Particular phosphorus may be present in soil particles and mineral containing aluminum, iron, or calcium, or with organic matters. Where dissolved phosphorus is readily available in algae, a particulate phosphorus is unavailable or gradually available to aquatic organisms, whereas particulate phosphorus has occurred in stem beds and lake beds, slow The release of dissolved phosphorus from sediments can be a cause of phosphorus for many years, and the source of phosphorus are as follows. Point source which is wastewater treatment plants, industrial effluents, sewages, sewers, whereas non-point sources are farm, rural or urban runoffs with excessive fertilizer, herbicides, insecticides. Okay. Other non-point sources are oil, grease from urban runoffs from improperly managed construction sites, crops and forest lands, and eroding stream banks, bacteria and nutrients from pest washes, livestock and faulty septic systems. Usually non-point sources contribute 80% of the phosphorus and point sources about 20%. The nutrification I have told before, when excess of nitrogen phosphorus is in alarm in the most aquatic ecosystem under natural condition, when bacteria are not present in the landscape, phosphorus and nitrogen is generally in short supply. In short supply, limiting the growth of algae and aquatic system. But when it is excess, they will grow too much, which will lead to the algal bloom, and these algal bloom they will grow, and once the sulfur and nitrogen get consumed, the growth they will die, which will lead to the eutrophication. This process is called as eutrophication. Okay. Then color. Color in water may be due to occurrence of colored organs, organic matters like humic substances, metals, irons and magnesiums, or colored industrial waste. Drinking water should be colorless. Variation in the color of water and the presence of new color heads as indicator, then more investigation is needed. Taste and odor. Odor in water are produced mostly by the occurrence of organic substances. Some odors are revealed or increased biological activity. Other may be consequences for industrial pollutant. Usually the taste bud in the oral cavity sends the inorganic compounds like metal such as sodium, magnesium, copper, due to which water tastes different. Then fluoride, over 65% of endemic fluoride is caused by fluoride contaminated drinking water, which harmfully affects teeth, bone and soft tissues in human and animals. Fluoride concentration above 1.5 mg per liter in drinking water is consumed by 200 million people worldwide. Excessive fluoride concentration is more than 20 developed and developing countries has been reported in Mexico, Central and Western China, Kenya and South Africa, including India. According to a survey, 20 states and union territories in India, 20 million people are affected by fluoride contaminants. 16 million people, along with 6 billion children below age of 14 years are at risk. Then heavy metals, areas that are polluted by domestic and industrial sectors have high chemical concentration in groundwater. These concentrations are controlled by 6 mechanisms as following: interaction of interstellar water and geological sediments, interface and mixing water along freshwater and salt water boundaries, leaking causing up permanent, periodic and episodic admixture processes, then admixture of deep groundwater along with tectonic structures, different solubility behavior. Okay, so mainly your industrial activities lead to the addition of heavy metals to water, and these are harmful. One of the common is arsenic. Okay, water different oxidation, then manganese in water, like other nutrients, both deficient and excess can lead to severe metabolic disorders. Then biological parameters of water quality. Biological signal factors that govern quality. It is more vital than physical and chemical parameters as it has direct effect on public health. Some significant biological characteristics appear affecting quality of water include presence of bacteria, virus, pathogen, algae. Human and other animals release large number of intestinal bacteria stools and urine. So intestinal bacteria, which are usual flora of intestine, are not pathogenic, although other bacteria causing serious disease when they are present in water. Such pathogenic bacteria including Salmonella, Shigella, Vibrio cholerae, Yersinia enterocolitis. So these are harmful bacteria and should not be present. Okay. So occurrence of pathogenic intestinal bacteria is checking by distinguished intestinal normal flora. Such organisms which are habitually checked for quality of water is known as indicator organism or fecal contamination. For example, fecal coliform E. coli, fecal streptococcus, and Clostridium perfringens. Apart from factory, it is essential that drinking and domestic water be free from viruses. Viruses for intestinal tracts of a diseased person get access to the water along with feces and sewage. For example, rotavirus, poliovirus, hepatitis A and E, etc. Numerous species of protozoa and helminthes that source waterborne disease contained water through stools of infected patients. Example of pathogenic parasites are Entaomega histolytica, Graderia, Balastidium coli, etc. Every growth of algae in water disturbs the quality of water by many ways. Algae imparts characteristic color, odor, and taste to water. Also, algae adverse diffusion of sunlight to the bottom of the water. Bottom of the surface, aquatic bodies affecting photosynthetic organisms. Then, moreover, some algae produce toxic compounds, for example, Anabena and nostoc. So our drinking water should be free from all these Anabena, nostoc, neurotoxin, microorganisms, so that we are healthy. So what are the water quality standards and guidelines? The ability to good quality water is decimal features for preventing disease and improving quality of life. Bureau of India standards, BIS, water quality standards of different water parameters have been given from table 3 to 7. So these are the parameters, okay, for standard of physical parameters for drinking water, standard of bacteria parameter for drinking water, standard for general parameter for drinking water. Then toxic substances, how much should be and should not be there. Surface water quality criteria plus class A, B, C, D, and E. Effects of water pollution I have already discussed before while I was teaching. Okay, water pollution. We know that health effects, regular biochemical and metabolic reactions affect photosynthesis, dissolve oxygen, pH, gastrointestinal irritation, affects enzyme kinetics, corrosive, affects aquatic life, TDS, affects kidney and heart function, laxative or constipation effect, gastrointestinal irritation, corrosive to water supply system and causes hardness, TDS. Then hardness, skin irritation, worsen some health conditions, cancer, diabetes, etc. Poor leather when detergent cloth quality deterioration. Magnesium deficiency, hypertension, cardiac and cardiovascular disease, diabetes mellitus and osteoporosis, poor lather with detergent. Calcium deficiency, osteoporosis and hypertension, poor lather with detergent. Then laxative effect, chlorine, corrosive deleterious effect on plant and can clog water pores if it is in dissolved condition. Methamoglobinamine in infants and so due to sodium, algal bloom, adverse impact on aquatic life. Then phosphate, digestive problem, eutrophication, sulfate, laxative effect, gastrointestinal tract. In hypertension, heart disease, kidney related problem. For sodium, there can impact salinity hazard, aluminum kidney disorder, neurological problems, prevents nutrient uptake by root, interferes with gill functioning. Heavy metals, most of the heavy metals affect liver and kidney. Most of the heavy metals affect microbiology. Functioning, ATPase, inhibitory degradation enzymes and transport. Then lead causes anemia, hypertension, irritation, behavioral changes, and impaired intellectual adversely affects the nervous system and kidney. Behavioral changes in animal required then cadmium, Itadian anemia, insomnia, loss of consciousness, respiratory, renal, and cardiovascular problems. Then decreased osmoregulation growth in aquatic. Chromium, liver and kidney damage, reduction fertility and revival in aquatic organism. Arsenic cause hyperkeratosis, carcinogenic effects and gastrointestinal tract, cardiovascular disease, bioaccumulation, behavioral effects. Manganese develops failure after bone and cartilage grow. Then pneumosclerosis, brown spot formation on plant leaves, leaf withering and staining. Then nickel, allergy, dermatitis, growth reduction, damage gills in fishes, toxic to plants. Selenium, fingernail loss, heart and muscle problem, reproductive familiar and birth defect in organisms, damage gills in fishes. Then uranium, carcinogenic and nephrites, radioactive, no bioaccumulation. Copper, hypertension, neurological issues, liver and kidney dysfunction, damage gills and kidney in fishes, restrict growth of aquatic animals. Silver, then mercury, in disease, allergy, brain damage, negative reproductive effect and DNA damage, damage vital tissues and organs of fishes, reduces reproductive success. Cobalt, anoxia, nausea, diarrhea, thyroid damage, heart problem, bioaccumulation, dissolved oxygen, low DO level indicates polluted state of water, regulate quality and quantity life, aid in degrading organic matter, lake, ocean and stratification. Biological oxygen demand, BOD level hazardous, affects water quality. Chemical oxygen demand correlates to ill effects on human health, algal bloom and seafood contamination. Hypoxia water reduces cell function, death and aquatic organisms. Bacteria causes of dysentery, salmonella, cholera. Some aquatic animals. Just a minute.